Okay, let's now talk about functions of several variables. So far, we've just talked about functions with one variable, like, for example, r of t is a function of one variable, which is t. T is the variable. But um, in real life, most things depend on two or more variables. Like area is of a, say, triangle is 1/2 times the base times the height. So area is a function of the base and the height. There's two variables there. Or cost um, of manufacturing, say, an item depends on the cost of materials or what materials you use, depends on your labor, storage, and many other things. So cost can be a function of more than two variables. So the definition is the same pretty much as for one variable, but let's just do two variables. A function of two variables is a relation that matches or pairs each ordered pair xy, and these are real numbers, to only one real number. So it has the same wording as a function of one variable. And what happens is it takes an ordered pair into the real numbers, a real number. So the domain is all of these sets of ordered pairs in the real number system, and the range is f of xy, which is one real number. It's a unique real number. So for an example, let's let f of xy be sine of x squared plus y over the square root of xy. And we'll find f of 2, 1. So that's going to be the sine of 5 over the square root of 2, which, if we use radians, is negative 0.68 approximately. So we have this ordered pair, 2, 1, being sent to the real number, negative 0.68. And the domain of this function, notice that your denominator has a square root and your denominator can't be 0, so xy, the expression inside the square root has to be greater than 0. It can't equal 0 either because you can't have 0 in your denominator. So we're going to be looking at the domains of these things. So the graph of this is the graph of the equation z equals f of xy, and it's going to be in 3D, 3 dimensions. Let me draw a picture kind of what's happening. X and Y. So the domain are all these points here, and we can call those points x, y, 0, and they're getting matched. So this distance here is f of x, y, Let me put that in red. Okay, so this distance here is f of x, y, and the set of all those points is like a surface. And f of x, y is the distance from the xy plane to the surface. So that's going to a point on that surface. So each of the points in this flat domain are getting sent to a point on that surface. So say we want to sketch z equal the square root of 25 minus x squared minus y squared. Okay, first off, the domain, whatever's inside the square root has to be greater than or equal to 0. So if you solve that, that means x squared plus y squared has to be less than or equal to 25. So it's the points in and on the circle, center 0, 0, radius 5. So you have this in the xy plane, that's your domain. Your range, since this right here is less than or equal to 25, z is going to be between 5 and 0 because the square root is positive, so it has to be bigger than 0, but it can't be bigger than 25. So the square root of 25 is 5. So what you get is if you let z be constant, these are called the level curves. They're circles. And the radiuses keep getting smaller and smaller as k gets larger and larger. So here's your domain, and then the level curves are going to be circles. So you get a half a sphere, you get a hemisphere with radius 5. And what is the level curve? Well, as the point xy moves along that curve, that means the value of f of xy remains constant, k. That's what your k is. So if you want to sketch these things in Maple, you would first use with plots, you would call up that package because we're going to sketch. We put a colon there because we don't need to see the output. If you want to put a semicolon, then you can see what kind of commands you have there. And then you could just say plot 3D, let's make one up, minus x times 3 times x times y x cubed minus 3 times x times y squared, and then you set your domain x equal from A to B, whatever that is, you put numbers there, and then you have y equals C to D. So you set your domain, your x and y values. And don't forget your semicolon. And that will give you a good picture of your curve. And you can also do this with 3 independent variables. And that would just look like f of x, y, z. So you could talk about a function with as many variables as you want. Now, also in Maple, let me go back to Maple. Another command you can use is implicit plot 3D. And here you can have the z in it. You can have z equal I'll just keep that the same. And then you let x be whatever and y be whatever, and then semicolon. So you could use either command and you get a pretty good picture. All right, look at some of the example homework problems to help you with your homework.